red. Cool? Okay, so we're picking up where we kind of left off in the middle of lesson 2.2. Right now we're going to talk about vertical and horizontal lines. Is that getting where you can see it a little better? Okay. We talked about vertical and horizontal lines a little bit on the first day that we started doing this. That would have been Monday. It says the equations of vertical and horizontal lines do not require any of the preceding formulas. You don't have to do slope-intercept formula. You don't have to do point slope. It's a lot easier than that because your slope is either 0 or undefined. Okay? And so we get to be where we just have x equals a number or y equals a number. If it's vertical, that line is going to cross the what axis? X axis. So it's x equals. If it's horizontal, which axis is your line going to cross? So those are y equals. They do a little bit of trying to talk you through that in the textbook. Really what you need to know is the equation of a vertical line is x equals c. I would write that down, this part right here. The equation of a vertical line is given as x equals c. The equation of a vertical line is given as x equals c, where c is a constant, just a number. Okay. So what that's saying is this line crosses the x-axis at some value where x equals c. Questions on that? Okay. And so then if we kind of look further down in the text, it says the equation of a horizontal line, so this we want to write down. The equation of a horizontal line is given as y equals c. Equation of a horizontal line, y equals c. And so that's going to be a line that intersects the y-axis at some value c. Okay, could be positive, could be negative. We don't know. Any questions on that? Okay. And also in the book, they go through finding the slope of both kinds of lines. If I were to do y2 minus y1 over x2 minus x1, for a horizontal line, I end up with y equals 0. If I plug that into slope-intercept form or point slope form, all I'm left with is y equals my number.
So on the homework, did you just give you 2 points and you figure it out?
Yeah.
Pretty much you just look at the points and they tell you.
Right. You're either going to look, both x's are the same, so x equals that number, or both y values would be the same, so y equals that number.
So you're
Okay.
really just
And then we're just trying to find out what y and x are in the homework.
You can just
Well, for this part of it, there are lots of examples here. But yeah, that's how you read if it's a vertical or a horizontal line. Yeah. So if you wanted to draw this picture, you could. This is just an example of a vertical line at x equals -3 and a horizontal line at y equals -2. Good? Any questions on that?
So it won't give you like actual 2 points. It'll give you.
Well, it could. What if it was giving me the points for this vertical line right here? They use this blue color, so let's see. They could have given me the point -3, 2 and -3, 5. And they might say, what's the equation of the line that passes through these 2 points? Well, if you went in and did slope, you would do y2 minus y1 over x2 minus x1. And when you have those in the bottom, -3 plus 3 makes what? 0. Uh-oh, I've got 3 over 0. So what's my slope? Undefined. Can't divide by 0. That's a no can do. So if I'm undefined on my slope, then I must be dealing with a vertical line. But you could also see that by looking at your points. If my x values are the same,
Yeah.
then I've got x equals -3 as my equation.
Somebody's popular.
Oh. Are we good on that? Any other questions here? No? Okay. That's the end of that slide. So we'll go to the next one. Hello. There you are. Okay, so example 13. This is the first example that goes with this information. It says, find the equation of a line passing through the given points. This is example 13. Find the equation of the line passing through the given points. And your 2 points here are 1, -3 and 1, +4. 1, -3, 1, 4. Okay. Some of us are picture people, and we really benefit from seeing what that looks like on a graph.
Your x's are the same.
Yeah, your x's are the same. If I plot those 2 points, I'm plotting 1, -3, so over 1 down 3, and 1, up 4. Visually, I can see the line that passes through both of those has got to be a vertical line, right? But if I didn't have my head kind of on a swivel about that, I might say something like, hey, find my slope. I've got 1, -3, and 1, 4. If I go m equals y2 minus y1 over x2 minus x1, I'm going to have 4 minus -3 over 1 minus 1. 0 on bottom. It don't even matter what's on top, right? Now I know my slope's undefined. This must be a vertical line. M undefined, x equals some number. That's given. X equals what number? What number does this line pass through? 1. Okay. I ended up with a 7 on top, but it wasn't necessarily, it didn't matter. Do we want to do the try it, or are we okay with that? Do the try it? Okay. Let me get rid of this. It's fine, I'm just erasing. Okay, so our try it here says find the equation of the line passing through -5, 2 and 2, 2. So if I do x1, y1, x2, y2 with these 2 points, and I find my slope, m equals y2 minus y1 over x2 minus x1. Plug in, I've got 2 minus 2 divided by 2 minus -5. Now it's not my x's that are the same number. It's my y's. 0 on top. I got a 7 on the bottom, right? 2 plus. 7 on the bottom, but who cares? 0 divided by 7 is okay. What's my slope? If 0's on top, it's okay. Slope is 0. What that means is it's a horizontal line. Where does it cross the y-axis?
At 7.
Read your points. What are your y values? 2. 2.
Okay, 2.
So the equation of this line is y equals 2.
That's all you read?
And if you struggled with that, plot your points. The first point's at -5, 2.
So why do we write m equals undefined and then x equals 1? What is m?
Slope.
Okay.
M slope. You see how I just plotted those 2 points and they ended up on the same horizontal line? Okay. All right, let's go on. Next, we're going to talk about parallel lines. Okay. So can you see this picture?
Yeah.
It says determining whether graphs of lines are parallel or perpendicular. So if we're reading here, it says parallel lines have the same slope. Parallel lines have the same slope and different y-intercepts. You want to write that in your notes. Parallel lines have the same slope and different y-intercepts. If they have the same slope and the same y-intercept, what are they?
Perpendicular.
Nope. Same slope, same y-intercept. They're the same line. Same slope, same y-intercept would be the same line. So parallel lines have to be separated a little bit. They have to have different y-intercepts so that they're spread apart. But they have to have the same slope so that they run like railroad tracks that would actually never cross. Parallel lines have the same slope and different y-intercepts. Okay, so lines that are parallel to each other will never intersect. You see 3 different lines with slope m equals 2. Look down here. You've got equations in the bottom corner of this picture. These equations say m is 2 every time. One starts at -3. It's a little lower. The second one, the orange one, starts at 1. It's a little higher. The third one starts at 5. It's a little higher than that. If they weren't spread apart with different y-intercepts, they'd all be the same line. Is that making sense now? Different slopes. Different y-intercepts, same slope. Okay, so let's look over here. This is going to be perpendicular lines. Perpendicular lines intersect to form a 90-degree angle. The slope of one line is the negative reciprocal of the other. Okay, so let's say this. Perpendicular slopes are negative reciprocals. Negative reciprocals. Perpendicular slopes are negative reciprocals. So what that means is if I have one slope, m equals +3, m perpendicular is going to be flip it, so 1/3, and change the sign, -1/3.
What if the original one's already negative?
Great question, Duncan. What if the original one's already negative? So m equals -1/2.
Positive?
M perpendicular is +2. Great question. So you're going to flip it and change the sign. Okay. And so if you look at the picture that they have here, you'll see one line is at y equals 3x minus 1, and the other line is y equals -1/3 x minus 2. Could it be that they have the same y-intercept? Would that be allowed?
No.
It could be. If these two had intersected actually just a little bit step over, they would have had the same y-intercept.
It's fine if they're the same y-intercept.
It's fine if they have the same y-intercept.
They can meet at any point.
They can meet at any point. But their slopes have to be negative reciprocals of each other. Versus parallel lines don't have the same y-intercept. Never. They have slopes that are the same. Okay?
So today is that on the thing?
Uh-huh.
Homework?
So let's do example 14. It says graphing two equations and determining whether the lines are parallel, perpendicular, or neither. I'm going to cut you some slack here and not make you graph these. I just want you to be able to compare the equations. Okay? If we get stuck in the weeds with graphing lines, we'll never move on. So we're going to just look at the equations and we're going to be able to tell, are they parallel or perpendicular or neither? So write these two equations down right now. We've got 3y equals -4x plus 3. And then we've got 3x minus 4y equals 8. Before I can compare the slopes on these two lines, what do I need to be able to do?
Of the y by itself.
Got to get y by itself. Got to put them in slope-intercept form. 3y equals negative 4x plus 3. And 3x minus 4y equals 8.
So you need to put the x and the y.
Perpendicular.
Okay? Give me just a second to get to the second one. Let's isolate y on the first. What are you going to do?
Yeah, flip your y and your x.
No.
No, we need x. We need y by itself on the first one. So
You divide by 3.
just divide everything by 3. So y equals negative 4/3 x plus 1. Right? 3 over 3 is 1. So what's my slope from line 1? Negative 4/3. Okay. Now we want to rearrange the second equation here so that we can tell what its slope might be. So what's the first thing we're going to do? Minus 3x. So move x stuff. Do y'all remember this from yesterday? Minus 4y is equal to, I want to be smart about how I write these things. Put your negative 3x stuff first. Put your 8 after. That's step 1. Move x stuff. And then step 2,
Divide by negative 4.
divide by negative 4.
Which is going to be positive.
Okay. So finally, my equation is y equals positive 3/4 x. What? Minus 2. Positive 3/4 x minus 2. So the slope that I have from this line is 3/4. Are the two slopes negative reciprocals of one another? We've got negative 4/3, positive 3/4. Flip it, change the sign. So what can we say about these two lines? They're perpendicular. You need to write that out. The two lines are perpendicular. Do we need to try it? Are we okay? Okay, veto the try it. The two lines are perpendicular.
On our homework, we just have to decide if it's perpendicular or parallel.
Yeah, I won't make you graph them.
Okay.
If you touch it with 2 fingers, it does okay. If you touch it with 1, it thinks you're trying to write. It's frustrating. All right, so writing the equations of lines parallel or perpendicular to a given line. This is going to be the last kind of thing you have on your homework. Okay. So as we have learned, determining whether two lines are parallel or perpendicular is a matter of finding the slopes. To write the equation of the line parallel or perpendicular to another line, all you need is the slope from the existing line. Okay? Doesn't matter about the y-intercept. That's got nothing to do with parallel or perpendicular. You got to find the slope and then go from there. Okay, so if you need the how-to, find the slope of the given line. That's where we start. Use the slope and the point that they tell you for your new line. Write your equation and then simplify in slope-intercept form. Okay. If you want to write this stuff down, you can. If not, we'll just attack the example and start walking through it. Y'all want to write this down? No? Yes? Okay. Find the slope. Use the slope and the given point to write a new equation. Find the slope of the given line. Use the slope and the given point to write the equation of a new line. Find the slope of the given line. Use the slope and the given point to write the equation of the new line. Ready, set, go?
Yeah.
Okay. All right, so example 15 says write the equation of a line parallel to the given line passing through the given point. Write the equation of the line parallel to the given line passing through the given point. So I would not write the given line passing through the given point part. If I were you, I would write down example 15 and write the equation of the line parallel to 5x plus 3y equals 1. Parallel to 5x plus 3y equals 1. And passing through the point 3, 5. So example 15, write the line parallel to 5x plus 3y equals 1. And we want it to pass through the point 3, 5. And we're trying to run parallel to this equation. So the first thing we need to do is get the slope of this given line. How do we do that? Yeah, move 5x. How would you move it, Joseph? Subtract 5x from both sides. Same way we did this earlier. So now I have 3y equals negative 5x plus 1. Divide everything by 3. So y equals negative 5/3 x plus 1/3. What do I know about this line? Our slope of this line, m, is negative 5/3. That's all I need this old line for. I just needed the slope from it. Okay? So at this point, once you've gotten the slope, you don't need this guy anymore. We've got to write a new equation. And our new equation needs to be parallel to this old one. So what's the slope going to be for my new equation? Also negative 5/3. That's how we keep it parallel. We have the same slope. And our new line is going to go through the point 3, 5. So now we're ready to go to work with new information. What do I use this point for, 3, 5? Sure, you could go point slope form. I think slope intercept is where we should end up. Some would say solving for b is the hard way. Okay. Let's go point slope first. On the next one, we'll do slope intercept. Okay. So y minus y1 equals m times x minus x1, where y1 and x1 are these two values, 3 and 5. So we're going to have y minus 5 equals, what's my slope? Negative 5/3 times x minus, what's x1? And then all we have to do now is simplify. Distribute that negative 5/3. So negative 5/3 x. What happens when I do negative 5/3 times negative 3? Positive. My 3's cancel. Positive what? 5. Equal to, what's on the left? Y minus 5. Now we're going to swing that 5 all the way over. So y equals negative 5/3 x plus what? 10. Y equals negative 5/3 x plus 10. Okay. What do you think? I know. Y equals negative 5/3 x plus 10. And this one that we started with was y equals negative 5/3 x plus 1/3. Do they have the same slope?
Sorry.
Is that better?
Her head was in the way.
Do they have the same slope? Do they have different y-intercepts?
Yep.
Are they parallel?
Yep.
Okay, then we did great. We only have one more example here. You got it in you?
Yep.
Yep. All right. All right, so the last example here, I'm going to cut this and put it on the next slide so that we have room. There we are. All right. Find the equation of a line perpendicular to, so we're running now perpendicular to 5x minus 3y plus 4 equals 0. Okay, so perpendicular, this is example 16. 5x minus 3y plus 4 equals 0. And our new line needs to pass through the point -4, 1. And we'll use that information in a little bit. For now, what do we have to do? We got to solve the first one for what? What are we looking for? We got to get the slope, right? So we're going to isolate the y value so that we can find the slope of the original line. How do you isolate the y value? What do you want to move first? I'd move the 4. -4 minus 4. So 5x minus 3y equals -4. Okay with that? Then what would you do? Minus 5x, move x, move x. So -3y equals, what do I want to write first? -5x minus 4. And then? Divide everything by -3. So y now equals positive 5/3. How'd that go to positive?
Because it's negative.
Yeah, and a negative divided by a negative. Now I got a positive. And I have it also a -4 divided by a -3. I'm going to call that plus 4/3. The only thing that I need off of this line is the slope. I don't need anything else. Okay, so what do I know? M for my new line
It would be -3/5.
so my old line M is 5/3, right? M perpendicular to 5/3 is going to be -3/5. Okay? Once I have that information, I am done with everything about my old line. And I'm ready to write an equation of a new line that goes through -4, 1 and has a slope, what? -3/5. Last time we did point slope. This time let's do slope intercept. Is that okay with y'all? So y equals mx plus b. Y is going to be 1. M is -3/5. X is -4 plus b. We're doing all right? When I multiply these two fractions, I don't actually see two fractions. I just multiply the -4 by the top. Just the top, not the bottom. So -4 times -3 makes positive 12/5 plus b equals, I could write 1 right here. Yeah, so imagine that was -4 over 1.
Why would you write 1?
Is -4 times -12 -3 makes positive 12.
Yeah.
1 times 5 makes positive 5.
Yeah.
Anytime I have where did I lose it? Do you know?
Yeah, this went from 0 to 100 real fast.
Okay. At some point, we lost the recording. I'm not sure where that happened. So I just want to make sure we've got it written down right. We went from 1 to 5/5. We subtracted the negative 12/5 from both sides. So now b equals negative 7/5. And then we're writing our equation, y equals negative 3/5 x minus 7/5. Okay?